The first steps for combination of CGM and glucose delivery was focused on hypoglycemia prevention. So the first systems were composed or were made so that the sensor would stop insulin delivery from the pump in case of reaching a low threshold of glucose. So it was a stop in case of reaching this threshold. The next step was to try to stop the pump before hypoglycemia. So it was a predictive low glucose suspend. And the last step was to adjust insulin delivery in case of hyperglycemia. So it was both hypo and hyper prevention. And so the systems now are working this way, so that in case of decreasing glucose level, it stops insulin delivery. In case of glucose moving up, it promotes higher insulin delivery. Most of the systems are using model predictive control algorithm, so that it means that from the CGM data, it will predict what will be glucose in some hours, and from that, insulin delivery will be adjusted to keep glucose in range. This is the most common system now, algorithm now. There are also some PID systems which are more reactive. But with sub-Q insulin delivery, it's working better with model predictive control. From the patient side, the difference are mainly related to what can be adjusted. The length of action of insulin, of course, the type of insulin also can be different according to the systems. The bolus adjustments can also, which is not the automated part, can also be different according to the systems. What may be different also is that some sensors have to be calibrated, whereas other sensors don't need any calibration. So there are slight difference between the systems, but most of the systems are giving the same performance. It's only a matter of adjusting a few differences. So it is a bit like cars, you know, they are all working on the road, but you have slight difference in the way that you can drive your car. Well, the loop is where people who were not really involved in the industrial process, of course, because they considered it was too slow. And so they tried to make some wild connections between pumps and sensors, and so that they would be connected to available algorithm. They don't do so bad, but the problem is that the connections are not safe, and so they may experience some hypoglycemia or hyperglycemia. So what one would expect from closed loop systems. And so it was show to the industry how they should build the closed loop systems. So they were innovative. They provided some important input for the development, but at the cost of a higher risk because it was not safe. So we should not recommend using do-it-yourself system. But what the people think is very important. So it's very important to know what they're expecting from closed-loop systems. Well, our hope is that artificial intelligence will hope to fully close the loop, because currently, as you said, it's a hybrid closed loop. So the patient has to interfere to say what he will eat, if he will do sport, and so on. What we may expect from artificial intelligence is that due to the treatment of the signal from the CGM, it will help recognize when the patient is starting to have food and to fully automate to make the system fully automated. So If the artificial intelligence can also better predict what will happen in forthcoming areas based on what happened on previous days, to have more reactive systems, more systems that will more anticipate what will happen. So artificial intelligence will be an important component to make a closed loop fully automated and with better anticipation. Well, the first wish would be that most patients with type 1 diabetes could have immediate access to these systems, because it improves quality of life, it improves glucose control. So system that would be widely available is first wish. Second wish would be that it's fully automated, so that they have a full benefit of this closed loop. It's still a burden to count the carbohydrates, to adjust the bolus, to mention that they will start sport. Third wish would be that the system would be smaller, so that it could be less visible, hopefully implantable, because as you know, in some part of the life, it's better that you don't have to show that you have a pump, that you have a sensor. So if the system could be all in one, and if possible implantable, I think it would be a nicer way for the patients.